Okay, so this is going to be the answer key for the guided notes nomenclature. We're just going to kind of rip through this fairly quickly, starting with how you determine which nomenclature to use. It's either going to be an ionic nomenclature, metal and a nonmetal, or covalent nomenclature, two nonmetals. And so as you see with these first ones, you have to determine which it is. And here's the deal. Look for the metal. If there's a metal on the first one, it is an ionic nomenclature. Si, if you look on your periodic table, Si here is right here, number 14. That is a nonmetal. It's to the right. So that is not going to be an ionic compound. And that's how you're going to do all of these. So look for the first one. S, Cl, and Si are all nonmetals. The only metal is MgO. So that is an ionic bond, metal. Same thing over here. These are all metals. That's nonmetal, so on and so forth. So make sure you know how to do it, because if you don't know which one's the metal or which one's the nonmetal, you can't go into the correct nomenclature. What's the correct nomenclature? Well, if it's two nonmetals, if the first one's a nonmetal, you use prefixes. Monos, dis, tris, so on and so forth. And it's a real simple process. The two turns into a dinitrogen. The three turns into a trioxide. And you'll need this list. Mono, di, tri, tetras, penta, hexa, hepta, octa, nona, deca. SF4, sulfotetrafluoride. And then it goes opposite, tetraarsenic. Now, there is a key at this point in your nomenclature life. You can understand this. Don't switch. Tetra is 4. It goes with the arsenic. You don't switch. It is As4. Deca goes with the chlorine. It is Cl10. No switch. Nitrogen trichloride, NCl3. Pentaoxygen, don't switch. O5, heptafluoride, F7, and then the only exception is that we don't write the first mono. This should be mononitrogen dioxide. We take that first mono out. It is nitrogen dioxide. Dicarbon hexabromide, so on and so forth. So covalent nomenclature, use those prefixes, don't switch. All right, we're going to do a small transition into the ionic by going and talking about polyatomic ions. Polyatomic ions are ions that are so well held together that they don't break apart in the thing and they stay as like a single element. Now, here is what you need to know for nomenclature. Ates and ites mean polyatomic. You look them up on this chart. Ides, you're going to look up in the elements. So if you go to your backside of this, you'll notice all of these polyatomics have ates and ites. Down here, like sulfide, chloride, fluoride, the ides, for the most part, other than hydroxide, OH, stay down here. So that is one way to know if you're dealing with a polyatomic. It's actually probably the main way besides looking at it. So SO4 2 minus, notice as soon as you throw that little minus is up here, you're not talking about sulfur tetraoxide, it is sulfate. CO3 2 minus, carbonate. Chlorate is ClO3, and you just look these up on this chart. Phosphate, PO4 3 minus. Now, how does this work? Well, in ionic compounds, you don't use the prefixes. You just name them. Name the metal, name the nonmetal, throw an ide on. Or if it's what we were just talking about, polyatomic ions, name the metal, name the polyatomic, because there is no ides with polyatomic. So MgO, magnesium oxide. Al2SO3, aluminum sulfate. And one other way to look is see parentheses. Parentheses with a metal means it's a polyatomic. Now, you got to be careful because sometimes there are no parentheses, but that's a good rule of thumb. Aluminum bromide, calcium nitrate. Now, naming them is fairly easy. It's actually going backwards. That is a little complex. And the key is switching. Switching. You are going to use the back of the periodic table for ionic compounds, not necessarily for covalent. And you're going to use these little numbers up here, the ionic charges, and you're going to switch. Ionic charges, switch. So if I've got aluminum, I look on the back of the periodic table and I get Al3+. Sulfate, ATE, means a polyatomic, SO4 2 minus, and you switch. Al gets the 2 up here from the SO4. SO4 gets the 3 from the aluminum, so it's Al2SO4 3. Plop the polyatomic in parentheses. Na2CO3, notice this CO3 is not in parentheses. You just have to recognize that it is sodium carbonate. CO3 is found on the back of the periodic table in the polyatomic ions. Couple of more just quick switches. Ca2 N3 minus, so it turns into Ca3 N2. Switch, switch, switch. These switches with the ones, they just drop out. And then the Li gets a 1. And notice I left the PO4 out of parentheses. If you want to put it in parentheses, by all means, do it. It's fine. And then the Li gets the 3. Okay, now we get to the worst and most confusing part, the multiple cations. So some cations, as you can see, they're almost always transition metals, even though there are a few here that are not. These have multiple potential things. And actually, the back of your periodic table has even more. So you can see Cu2 plus, Cu plus, Pt4 plus, Pt Fe3 plus, Fe2 plus, so on and so forth. So the problem is you don't know which one it is. So the problem will tell you by doing some sort of parentheses. That is 1 plus, that is 2 plus, and then all the other rules apply. So for instance, if I've got iron 3 oxide, that means it's iron 3 plus, and that's what I switch, Fe2O3. Now going backwards, what you have to do is a multiple step operation. So you are going to say, I have Cu2CO3. Your instinct would be to say copper 2, but that 2 did not come from copper. That came from carbonate. So you're going to break this apart, and you're going to say, I don't know what's happening in copper. I do know what's happening in carbonate. Carbonate is always 2 minus. Now, did the 2 minus drop directly from the formula? Yes, 2 minus. That means this over here is going to drop directly to that question mark. So this is actually copper 1 because the 1 came from the copper. Let's go down here and do a couple of other examples. 2's drop, and just note when you get the same subscript or multiples, you go to the least common multiple. So those 2's drop out and it turns into FeSO4. The 2's are there, but you divide them out. Here we switch. I get CuNO3 in parentheses 2, and then vanadium 5 V3 from the PO4, PO4 5 there. Now, let's do a little more time on the naming of them. So here's the process I'm going to do. Again, the copper is unknown, so I write it as copper question mark. That 2 comes from SO4 2 minus. So I write the SO4 2 minus, and then I look. Does that 2 match that 2? Yes, it does. Check. That's what that little check mark means. That means I can just drop this 1, because it's an assumed 1 around the SO4. It is not a 4. That 4 goes with the O. SO4, which I conveniently put in parentheses here, has a 1 after it, so it's copper 1 sulfate. Okay, here, cobalt. Cobalt is our question mark. NO3, I know, because I looked it up on the back of the periodic table, is NO3 1 minus. Did that 1 match up with what's with the cobalt? Yes, it did. Check. So then I can just drop this 2, because this 2 came from the cobalt, boop, and this cobalt 2. Okay, now here is the hardest kind of problem I think that's going to be on the test. So let's look. Fe, I don't know. I put a question mark. Oh, I know from the back of the periodic table. It is 2 minus. So I look. Does that 2 match with whatever it dropped to the Fe? No, it didn't. That's why there's a no check. That's a check with a line and a circle through, in case you're wondering. How did I get this 2? Well, I had to multiply whatever is by the Fe by 2. So that means when I drop this number 1, that's what's behind the O, I also have to multiply it by 2. Why? Because they divided each other out. Just like up here, we divided these twos out, and I got 1 and 1. Here, I divided these two out to get 1 and 1, so I have to multiply to figure it out. So it is iron 2 oxide. That is confusing and it's hard. If you need help with that, come see me, and I'm happy to give you example after example until we can actually get that in your brain. Okay, here are the other answers. Switch, because it is a ionic, so it's Ca2 plus, the 2 comes here. Nitride, now be careful. Nitride means it is on the back of the periodic table down in the elements. Nitride, right here. It is not nitrate, which is up here. ATEs up here, IDEs here. So that is not a polyatomic. It is just regular N. Disulfur trifluoride. I don't have to do anything other than recognize that is a covalent compound, dis, tris, so I just plop them down. No switching. Di 2, tri 3, no switching. Cobalt 2 phosphate, CO3PO4, switch, switch, switch. It's got a metal in it. Potassium, metal, switch, K2CO3. Phosphorus penta, I see that penta. I know don't switch. Bromide gets the penta. P gets the 1 because there's an assumed mono there. And then this is our FeO that we did up here, where you switch the 2's and then they cancel out to FeO. Up here, non-metal is the first one, so I have to do dis and tris and bis. Carbon tetra for the 4. Fluoride, notice I dropped the first mono. This is a metal, so I just name it. Calcium nitride. This is a metal, so I name it nickel phosphate. But I have done this enough times to look at the back of the periodic table because I know it's in that funky area, and I see, oh no, nickel has 2's and 3's. That is a multiple cation, so I actually have to put which cation it is. And so I noticed that there's a 2 over here, so I know that it is nickel 2 phosphate because that 3 right here came from the phosphate. All right, another non-metal, so it is dinitrogen trioxide, a metal, so it's just magnesium nitrate. It is a metal, cobalt carbonate, but again, I've done this enough to know that that is in that danger zone. So I come here and look, oh, it sure is. So I need either a 2 or a 3, and I look over here and I see that there's nothing here. Oh, that's weird. So it should be a 1, but oh yeah, I remember that it's cobalt 2 minus. The only way to get rid of the 2 that drops here from that 2 minus is to have another 2 here, and that 2 came from the cobalt 2 carbonate. All right, let me know if you have any questions about any of these problems.